So today we're going to talk about Pure Storage vVols, which is as a game changer for database as a service. And I am a staff solutions architect focusing on business critical apps at VMware cloud business unit. Sudhir?
Good morning. I'm a senior staff solution architect and the global Oracle practice lead for VMware. I specialize in Oracle technologies. Thanks, Mohan.
All right, so let's look at the agenda today. Sorry. So today we'll look at the typical customer challenges relating to storage and leveraging capabilities from storage for DB as a service. Look at VMware virtual volumes, look at some of its architectural components. We'll look at how are vVols different compared to traditional LUNs. Then we'll move on to Oracle workloads, where Sudhir will take us through all the nuances of running a database as a service. Then we'll look at some use cases and wrap up. So let's move on. So if you look at traditional storage, it's pretty arduous to manage. So that's what's represented on the left-hand side. It's slow to provision and rigid in deployment. You have to create LUNs or volumes for a specific capability, and it is pretty inefficient. And a lot of times it's a waste of space and money. Typically with large enterprises, you have storage admins who are required to make these changes. So whenever you need anything relating to provisioning, space allocation, replication, you actually have to work with storage admins, which adds to the time required to make any changes. If you look at the right-hand side, the virtual volumes can significantly change the way external storage is managed. It simplifies the day-to-day operations. It allows enables the granular management of VMs and their storage. It allows efficient control of I/O, provides easy management of snapshots, and it can also potentially increase performance. And it also can leverage storage policy-based management. So we look at all of these in the upcoming slides. So if you look at vVols, you can think of vVols as a well-orchestrated system of RDMs. Raw disks, like you are probably familiar with. So there is no file system. The virtual disks are natively present on the arrays. When a vVol data store container is created on the array, it's just an allocation or a quota of space and not a file system. Each vVol used by the VM has a specific function and a file system associated with it. Vendor-specific VASA provider is matched to the storage array's capabilities. This helps extend VMware storage policy-based management to the storage ecosystem. Storage policy-based management also uses the native arrays capabilities and can be applied at a VM level granularity. So that's, and in addition, it provides integration with the replication management. Replication can now happen at a VM level, even for array-based replication. LUNs or volumes are rigid and fixed in their capabilities. They require a file system, usually like VMFS or NFS. And there are some of the characteristics are shown above, right? With vVols, there is no file system. It's inside each vVol that's a file system is created, and that depends on the OS or the vVol's specific function. With vVols, changing the capability of a file system or a particular storage is simple. You just have to make changes to the storage policy, and the capability is changed with no storage vMotion or migration that needed. In the traditional sense, in the LUN or a volume, any kind of change like that usually require a storage vMotion. Depending on the array, you can even change things like spinning media to all flash dynamically, and the array handles all the migration aspects behind the scenes with no storage admin interference required. Another key aspect of vVols over traditional storage is that the array and vSphere have complete insight into the data and I/O requirements. So both sides can know what's happening from a performance standpoint and other aspects as well. So if you look at how a traditional data store is different from a vVols data store, logically, a vVols data store and a VMFS or NFS data store are the same. But it's how the vVols container is provisioned and utilized is the big difference. Each vVol data store corresponds to has a one-on-one correspondence with an array. So when a vVols data store or container is created on the array, there is no physical allocation of space. It's a quota, so to speak. There's a limitation set on its size. When created, the array creates a container and limits its allocation of space to the size you decide. For example, if you create a 5 terabyte container, there is no storage that is provisioned, just a quota of space, and where the contents will reside are decided. The other big difference is that capabilities aren't part of the vVols container. The capabilities are handled by the VASA provider, about which we'll look at in detail in the subsequent slides. And the storage policies are created from the published capabilities of the array. When a policy is applied and a VM is created, then the array creates the individual via vVols for that virtual machine based on the storage policy, and grants or limits the capabilities of the virtual machine based on the policies. So if you think about storage containers, as I mentioned, there's a 1:1 correspondence with data stores on vSphere. Storage containers are logical constructs for grouping the virtual volumes. Storage administrators define aspects such as the capacity limits and the capabilities. Maximum capacity is actually based on the physical capacity of the storage. So there is usually there's a virtual disk limitation of 62 terabytes. Otherwise, there is, the limitations of the vVols are primarily the limitations of the array itself, the physical limitations of the array itself. So now let's look at what exactly is a vVol. When a VM is created, there are a minimum of 4 vVols created. There's a config, data, swap, and mem. These are all separate vVols. If more disks are created on the VM, then additional vVols are created. There are other vVols that can be created based on some additional functionality. These vVols, the volumes that represent the data actually get a file system based on the functionality. And the file system can represent different OSs and is an OS-specific file system. So if you look at the different vVols and how they map to the different VM and its different vVols and how they map to the array, right? You see that each and every type of vVol gets its own type of vVol is mapped in the storage array as a different vVol. A config vVol, it's usually a small 4 gig VMFS LUN is created when a vVol is established, and this contains all the VMX logs, NVRAM, and log files relating to a virtual machine. The data vVol contains a raw LUN, and then the guest operating system's file system is laid on top of it. And so in the past, it was a VMFS on top of which we would then layer on like file systems like NTFS, ext4, and other file systems. In this case, the OS file system is laid directly on top of the data vVol. The swap vVol is created when a VM is powered on. It's the swap of the VM, and it's relative to the size of the memory. When the VM is powered off, the swap vVol is destroyed. And last but not the least is the mem vVol, and this is created when a managed or an unmanaged snapshot is taken of the VM. Because this is an array-based snapshot, there is no performance penalty that exists. We'll look at it a little bit more detail in the upcoming slides. Now let's look at what a VASA provider is. A VASA provider is critical for the vVol ecosystem. A VASA provider is a storage side software component that acts as a storage awareness API for vSphere. The VASA provider is an out-of-band communication between the vSphere host and the array. ESI hosts and the vCenter server connect to the VASA provider and obtain information about available storage topology, capabilities, and status of the array. It is a key information link between the array and vSphere. It is not the data link. No data I/O goes through the VASA provider. All I/O for vVols go through the protocol endpoints, and then we'll look at that in the next section. Each VASA provider is written by the array vendor for that specific array model, and therefore is unique to each array. A single VASA provider can manage multiple arrays. It provides storage awareness services to the vSphere environment. It also provides centralized connectivity to ESXi and vCenter servers. Now let's look at a protocol endpoint. Although storage systems manage all aspects of the virtual volumes, vSphere hosts have no direct access to the vVols on the storage side. Instead, vSphere uses a logical I/O proxy, and that's what is called the protocol endpoint, to communicate with the vVols and the virtual disks that the virtual volumes encapsulate. vSphere uses protocol endpoints to establish a data path on demand from virtual machines to their virtual volume. So the protocol endpoint acts as a go-between between vSphere and all the vVol components. For now, let's look at how a VM gets a vVol, right? And some of the mechanisms relating to vVol. We're not showing much of the animation usually associated with all these different activities, but for time constraint. But typically, the mechanism for coordinating the data path with vVols include binding, where it allows the array to create I/O channels for a virtual machine. An unbind operation is used for destruction of the I/O channel for a virtual volume to a given host. And the rebind operation provides the ability to change the I/O path for a given virtual machine while the VMs are still running. And these are usually happen, these activities for rebind happens when there's some array generated events that make it rebind, make it change the I/O path for a VM. So what does all this mean? So vVols are more efficient versions of LUNs. They are actually sub-LUNs. When any changes happen to vVols, there is no storage rescans that typically happen in a traditional LUN environment. Any kind of multipathing changes are not affected. So, and also there are much higher limits. We have 64,000 vVols that are supported per host, and then the container size can be 2 to the power 64. So now let's look at how do the capabilities of the array actually become storage policies. So on the left-hand side, you see all the different tiers. For example, we give you examples of a production tier where there's all flash storage, replication capabilities, encryption, snapshots, etc. We have like staging where the requirements are a little bit less stringent and maybe lesser quality storage is mapped to it. And then test dev, you see tier 3 storage, right? And so these kinds of capabilities are usually existing at the array level. And these can be mapped at a VM level using storage policies. So the storage admin creates storage containers, and then creates the capabilities and passes that on to the VASA provider. And then the VI admin then can register the VASA provider. And once the VASA provider is registered, the VI admin has access to all the capabilities of the array. And these capabilities can then mapped individually to different virtual machines based on the virtual machine's function and the tier and the relevant SLAs associated with that virtual machine. So now let's look at the benefits of vVols. We looked at all the different aspects of the vVol and the architecture in the past section. So now, if you look at it, LUNs or volumes, as we mentioned earlier, are rigid and fixed in their capabilities. They also require a file system like VMFS or NFS. With vVols, there is no file system. Also with vVols, the changing the capability is simple. With a simple change of a policy, the capability is changed when the policy is changed. There's no need for storage vMotion and data migration. Depending on the array, you can even change the type of media associated with the volume, with the particular virtual machine. The array also handles things like performance and data migration. Another key aspect of vVols over traditional storage is that the array and vSphere are complete insight into the data. In the past, the storage array didn't have any insight into what vSphere side was doing. But now with vVols, every virtual machine has its own set of files. And so the array also gets complete visibility into the activity at a VM level. vVols are faster. Because the array owns the vVols and capabilities such as snapshots, clones, replications, etc., the array's native capabilities are much efficient and faster, and they are actually the capabilities of the vVols. Clones and snapshots are offloaded to the array and not happening at a VMware level. VMware initiates the snapshots, and the activity actually happens in the array. And policy change and storage migration activity also is greatly accelerated because everything's happening at the array level. Okay, now when we look at vVols, who manages what? What does the VI admin see? We are comparing that to what a VI admin used to see in the past. Now the VI admin has complete insight to the virtual environment, and with vVols can manage also some of the tasks of the storage admin. And if you think about what does the storage admin see, the storage admin does not need to do a lot of the simpler tasks that like changing the capabilities, creating new data stores and others that they had to do with traditional LUNs. Now the storage admin also has complete visibility into each of the VM's disks and is able to manage the performance and be able to react to any events and other aspects that in the past they were blind to. And why are we still creating data stores is the other question. Because the vSphere and all of its features still use the concept of data store. Even in a vVol, we create data stores, but it's just an aspect of to preserve the interoperability. So before I handed this over to Sudhir, let's look at a comparison between VMFS versus vVols from a snapshots perspective. With traditional storage, snapshots are managed by vSphere. Although vSphere is efficient with snapshots, array can do a much better job with them. With typical vSphere snapshot, a secondary sparse SES disk is created and all new IO goes to that new disk. If the disk is not removed, it can continue to grow even larger than the original disk. Additionally, if more snapshots are created, then the chain of VMs can slow IO, as any read can end up going through multiple disks for the data. Consequently, performance of the VM can be impacted. When the vSphere snapshot is deleted, depending on how large the snapshot is and how busy the VM is, it can take quite a bit of time to delete. And this can affect performance. The longer the snapshot deletion takes, the VM's performance is degraded. And so that's a big impact on how snapshots affect VM performance. With vVols, as we've mentioned before, snapshots happen on the array level. And the array-based snapshots are point-in-time pictures of the data and take very little space. When a vVol snapshot exists, the I/O is not redirected and instead continues to go to the original disks on the vVol. Leaving a vVol snapshot alone will continue to grow and cannot be copied to another array, and even used as a copy or clone, and which Sudhir will go into much more detail. When a vVol snapshot is deleted, the snapshot is quickly removed with no impact to the VM. Regardless of how many vVol snapshots you might have, which is usually a maximum of 32, there is no performance impact on the VM. So now that we've looked at all the capabilities of the vVol and its architecture, now we look at Oracle specific aspects of the solution. So now I'm going to pass it on to Sudhir, and I'm going to stop sharing.
Thanks, Mon.
Full screen. Yes, thanks.
All right, thanks. All right, so going back to the previous slide. So essentially, Mohan spoke about the concepts of vVol, right? He spoke about the constructs of vVol, spoke about the different components that vVols has, right? Essentially, the storage container, the protocol endpoint, and the fact that we have vVols, which essentially are volumes, right? That can be attached to every aspect of a virtual machine, right? Whether that's a snapshot, whether that's memory, whether that's swap and config and so on and so forth, right? So in this section, we'll look at how Oracle workloads, they can take advantage of VMware virtual volumes, right? Whether that's with respect to day one operations or whether that's with respect to day two operations. This section will focus mostly on day two operations, right? So moving on. All right. Life of an Oracle database administrator, right? If you look at a typical life of an Oracle database administrator, right? So he and she, they will be spending 24/7 production support, and the fact that they'll be providing database services to the development teams, which include, database design, database generation, production support, creating databases, cloning databases, DB refresh, DB patching, installation, and so on and so forth, right? If you look at the and the workflow here essentially goes into what day zero is, what day one is, and what day two is, right? So our focus in this discussion today is mostly on day two operation, essentially trying to keep the lights on, right? Making sure that you provide DBA support to the developers, the architects, the QA, and the other database team, essentially providing backup and recovery, DB refreshes, cloning, patching, and so on and so forth. Right. So even before we go into how Oracle databases are able to take advantage of VMware virtual volumes, aka vVols, let's look at what database as service is, right? What are the benefits and what are some of the use cases, right? Essentially, your database as service or DB as a service, that's the ability to manage, monitor, and provision database resources on demand through self-service catalog with minimal requirements for, let's say, installation, configuration of hardware or software upfront. So the idea here is to allow the database consumers, right, the DBAs, the application developers, the testers, the architects, and the owners to provision databases easily, quickly, faster, using an on-demand self-service platform, right? So some of the benefits of database as service, some that comes in my mind, into my mind, right? Reduction of application time to market, right? So with using DB as a service, as everybody understands, it gives us the ability to rapidly develop, test, and deploy new applications at a fraction of time that it used to take with the legacy system, right? I mean, imagine the time when one had to go back and request for a physical server, then request for physical lunch, and then make sure that we have enough resources available before we could even walk, right, or chart the journey of installing a grid infrastructure, or let's say the RDBMS binaries, right? So the time to market is drastically reduced, right? The second benefit is automating. You're able to automate your database lifecycle management. I mean, if you look at any customer, if you look at any company here, right, the database sprawl, the DB sprawl, that's one of the major problems we see in many companies, because IT departments, they have very difficult, right? They have a difficult time trying to keep track of all the DB instances that are deployed, right? And this will have serious implications when you talk about, let's say, licensing, or when you talk about data governance or security standpoint. So DB as a service, we are able to tighten this whole database lifecycle management. We're able to make it easy, we're able to make it more flexible, and we are able to enforce the governance through what's called policy-based management, right? We are also able to increase the operational efficiency and resource utilization, right? Again, and one of the points that Mohan touched was, the distinction between the roles and responsibilities of the VI admin and the storage administrator, right? So typically right now, the storage administrator no longer has to spend time and effort in provisioning storage resources for databases. With concepts like SPBM, storage policy-based management, where one can define and say, well, I would like a storage which has these characteristics, right? Maybe it has a RAID 1, maybe it has RAID 5, maybe it has RAID 10, right? The fact that this underlying storage should have the capability of performing compression, or let's say dedupe, right? Can you, and then once we select, or once we come up with these storage policies, and if the VI admin, or let's say the Oracle DBA, were to go and pick that storage policy, he or she would then be able to see the underlying storage which has these characteristics, right? And so that frees up time for both the teams. So an important thing to keep in mind is oftentimes, right? Oftentimes, the storage performance, that is a limiting factor for handling database as service projects. So typically, if you look at magnetic, right? If you look at spinning Rust, the traditional disk-based storage, they are not able to meet the performance need for DB as a service. So because they are inherently too complicated to manage. All right. So we looked at what database as a service is. We looked at what it requires, what are the benefits, right? And the use cases here. Let's look at some of the requirements of business critical workloads. And when we say business critical workloads, it doesn't necessarily have to be the Oracles, right? That could even pertain to the SQL servers, the SAPs, the Microsoft application, so on and so forth. Any workload that essentially has stringent SLA, RTO, RPO, that is deemed as business critical, right? And they will have certain requirements like high availability, performance, recoverability, scalability, security, and so on and so forth, right? For example, the backup needs to finish in a timely fashion. So that could be one of the requirements of any business critical application, right? See, what happens is with virtualization of Oracle workloads, customers have many concerns. Right? When there are certain concerns, and we have divided the concerns here in this slide into two parts, right? The day one concerns and day two. So if you look at the day one concerns, right? Well, we have databases that have different levels of criticality, which means these databases, they need different storage performance characteristics and capabilities, right? Well, I have certain database that need to meet stringent SLA for performance, right? Unfortunately, I'm not able to do that because currently they are on slow traditional storage. So that's concerns pertaining to day one. Now, when we switch gears and talk about day two, right? Essentially, after the database is deployed, we have other challenges as well, right? The fact that the database is rapidly growing. So, which means the backup window would have to be reduced in order to meet the performance and business SLAs. And let me give you an example here, right? Let's assume that the production workload or the production business, that starts at 9 in the morning, right? So we go from 9 in the morning all the way till 6. The data warehousing job kicks in from, let's say, 6 in the evening all the way till 3. And we have a window from 3 to 6 in the morning to get all our day two operations done, right? The backups done, so that when the operation teams, they come in at 6 in the morning, they're able to do their task and make sure that business is ready at 9 a.m., right? So that 3-hour window, that's very critical to adhere to. And as the database is growing, it's very difficult to meet that SLA, right? Or make sure that the database backup completes within the 3-hour window. Same thing, right? When you have large database sizes, we have difficulties in cloning, right? And if you have to refresh data from, let's say, production, right, to QA or even to development environments, that becomes a challenge here, right? And if we start looking at technologies, right, in order to speed up the backup, for example, storage-based replication. Yes, we all understand storage-based replication is faster. But the cons to that is when you do a LUN-based replication, that causes unnecessary data to be copied over, right? So these are some of the concerns that affects the Oracle workload virtualization. All right. So These are some of the Oracle Day 2 operations. Well, we won't have time to go into each and every one of them, right? But on a very high level, Oracle backup and recovery, everybody here understands, there are multiple ways one could do Oracle backup and recovery. Essentially, the first way to do it is the user managed database backup, where essentially, if you have that level of SLA, you're able to shut the database down and do a cold backup, or you're able to place the database in a begin backup mode, take a snapshot or copy the data files, and then put the database back, or take it out of the begin backup mode by using what's called the end backup mode, right? That's one way to do it, or two ways to do it. The crash consistent backup, that's another way of backup that customers are doing it more and more predominantly, because you don't have to put the database in a hot backup mode. You don't have to shut the database down. There are certain criteria that has to be followed when one does the crash consistent backup using storage based snapshots, right? The fact that right order fidelity has to be preserved, the fact that the database has to be crash consistent when you take the storage based snapshot, and the fact that the storage should be able to write that snapshot time, or you should be able to capture the snapshot time when you take that snapshot. So these factors are essentially listed, and Oracle has a metalink document that basically says if you are able to satisfy these three criteria, then yes, you're able to take a crash consistent backup using storage based snapshots, right? Customers, they use Oracle RMAN. Why? Because Oracle RMAN doesn't do the hot backup method of backing up a database, right? It understands the blocks. It's able to make sure that the blocks are consistent, and then it dumps the block onto, let's say, a file system, for example, where you're able to use third-party media server to copy it and put it to tape, right? And then you have the Oracle data pump, export and import. Similar, cloning. You want to clone a database for application development. You want to clone a database for the QA team so they can test existing software or features, right? You want to test your backup and recovery. Or let's say if you have to test your patching, your upgrade, migration strategies, typically DBaaS would clone the databases to test it before they actually do it in production, right? Same thing about refresh. Well, I need to test this software, but my QA database is behind my production database by delta T, which means I need to refresh the dev or the test stale data, right? And again, patch, we spoke about that before, right? But these are typically some of these day two operations that Oracle DBaaS would have to do from time to time, right? So let's take backup and recovery as the use case here, right? There are many factors that affect the backup and recovery, and some of the factors are the level of backup. Trying to do a full backup versus incremental or cumulative. Everybody understands, right? Full backup takes more time than incremental or cumulative. The amount of data churn, how much is the data, how much data has changed between two incrementals or two cumulative? Well, that will also determine how much time the backup takes, right? What is the mechanism of backup? Are we dumping it to tape? Are we dumping it to a NAS drive? Are we trying to do it over network, which basically comes down to the fourth point, the underlying infrastructure? I mean, doing all of that will essentially affect the backup duration, right? And also affect the databases being backed up. And traditionally, people have seen that SAN-based backups, they have minimal impact on the infrastructure. So again, these are some of the factors that affect the backup and restore capability. All right. Again, taking Oracle database backup and restore as a use case here, if we step back and look at it, there are three ways you can trigger these operations. And this is not particular to backup and recovery. You could extend the same concept to cloning, or let's say refreshing or patching. On a very high level, you can trigger it in three ways. First is the application layer, the Oracle level. Second, the VMware level. Third, the storage level. Let's look at all three levels. See, when we are sitting on the Oracle level and taking a backup, right, what are the advantages? It has the finer level of granularity. My level of granularity is the table level, the data file level, or the table space level. What are the cons? It's not always the fastest, right? Remember, when the database size grows up, trying to do an ARM backup, that will take some time, right? When we come one level down to the VMware level, and when we look at it, well, the VM level granularity, that's ideal. I can take a VMware based snapshot, and voila, I'm done, right? But what are some of the disadvantages here? Virtual machine level snapshot, that might stun the virtual machine for some time during the snapshot coalescing and deletion. And there's a KB article for that. So that's why when we speak to our customers, we say, hey, if we have to do this snapshot coalescing and deletion, do it during a quiet time, right? Where you don't have any production jobs running, so you don't affect the database, right? And last but not the least, the storage level, the storage array level. When you look at that, the speed and the performance, that's awesome, right? But the problem here is something I've already stated before. It lacks the VM level granularity because operations are executed at a storage LUN level. It's the level granularity is not at a VM level or at a database level. Now, what is things that we want? We would like to achieve the speed and the performance of storage, But then we would like to combine that with a VMDK level or even with a VM level granularity. And that's the beauty of VMware vVols, right? VMware vVols technology provides that ideal solution to, to all the challenges that we spoke about in the previous slides. All right. So let's look at the architecture for Oracle and VMware virtual volumes and some of the use cases here. So this is the architecture setup. Essentially, it's a two-site scenario. It's also connected to the cloud. I mean, we don't have to go much into detail into what the architecture is. But if you look at site B, it has 4 ESXi servers, and it's connected to a pure X50 flash array for both the block file for FC storage and also for vVols, right? All right. The thing is, Pure Storage plugin, Pure Storage, they basically release a plugin for the VMware vSphere client, and essentially that simplifies, right? That simplifies the life, simplifies all of the operations and makes life simple for any VI admin or even Oracle DBaaS, right? The fact that the plugin is able to do all of these 4 things, right? Importing a disk, or able to restore deleted disk, or able to create a snapshot, or you're able to overwrite a disk, right? So this makes life very simple for the VI admin. So these use cases will be using the Pure Storage plugin, and then I'll be showing you the use cases as to how this plugin makes life simple for some of the Oracle Day 2 operations. So the first use case is the database consistent backup and recovery using Oracle RMAN and VMware virtual volumes based snapshots. Right. So we have 2 virtual machines in question here, right? On the left-hand side, we see there's a database server, right? And on the right-hand side, you have the backup server, the Oracle RMAN server. Essentially, the RMAN server or the RMAN virtual machine will have an RMAN catalog database where all these production databases are registered to. And essentially, that stores the metadata for these production databases. And the RMAN virtual machine on the right, if you notice to the text on bold red, that has a file system called /RMAN. Could be ext3, ext4, ZFS, XFS, and essentially that's what is used for us to dump our database backup to our RMAN database backup dumps, right? So keeping it very simple here, these virtual machines have several VMDKs for their operation, but we just wanted to keep it very simple. So essentially I have highlighted the VMDKs in question. So the database server would have the data DG or the data disk, and it has an FRA disk for archive log. The RMAN virtual machine essentially has the data disk, but we call that RMAN data disk for both the data redo and archive log, and it has that file system in question here. Operating system is OEL 8.3. We used Oracle 19.8, Grid and RDBMS with Oracle ASM library. So this is the workflow when one has to back up, right? This Oracle database sitting at the DB server, right? Using Oracle RMAN and then dumping that data onto the /RMAN file system on the RMAN virtual machine so that we can suck it up using any kind of third-party media software, right? So essentially, the steps are there. So first, we would register the database with the RMAN catalog. We would then take 2 RMAN backups for the control file. We don't have to go very deep into that. We would then synchronize the RMAN catalog with the production database. So that way what happens is the most recent archive log that's added to the RMAN catalog. So then you are able to recover it to the last second, right? To the most recent time, right? And this is where the fun starts here, right? We would take a snapshot of the Oracle virtual machine, the DB server, right? That's step number 1. And then what will happen is on the RMAN virtual machine, when you go to the web client, right? And when you go to configure and when you go to the plugin, right? Essentially, you have an option where you're able to say, use the import disk, right? So we would use the import disk option to create 2 VMDKs, right? A data VMDK and also a FRA VMDK from the snapshot that we took of the database server, right? On the left-hand side. So essentially, the snapshot that we took, we would then clone 2 new VMDKs from that snapshot, and we would attach those 2 VMDKs to the RMAN virtual machine. So essentially, the RMAN virtual machine now has 2 new VMDKs, right? The cloned VMDKs from the database server, both the data and the FRA. Then what we do is, the rest of the steps are very obvious. We would then log on to the operating system for the Oracle RMAN virtual machine. We would just scan those ASM disks using Oracle ASM scan disk command. We would then run the Oracle ASM list disk, and then we'll see all the ASM devices, including those 2 new disks that were cloned from the database server. We would then mount those ASM disk group, startup mount the database, vVol 19C up here, And then using the rman commands, we would then back up that database and then dump that database content onto the mount point /rman. I said it could be an ext, ext4, back it up using any kind of third-party backup software to Media Manager. And once the backup is done, we shut the database down. You can dismount the disk group, and we delete the disk, right? Now, again, the deletion of the disk is optional here, right? Because if this RMAN backup is something that we do on a regular day-to operation, which typically most customers do, there is no need to delete the new added VMDKs from the RMAN virtual machine. What we can then do is use the override disk option, right? On the Pure plugin, use that override disk option to overwrite new added VMDKs. And this is something that we could put in a workflow, like VRO basically goes and does it as a workflow, right? And this helps with the DB as a service, right? This helps alleviate the DBA time, so he and she can then focus on something which is more important to the business. And again, this use case has been described in detail in the link provided in the slide below. Let's say if I was not using the Pure plugin, right? Can I still do it? Absolutely, right? I can still do it. So, but there would be some manual steps that would have to be done, right? Essentially, I would take the same snapshot on the Oracle virtual machine, the database server, and then either using ParseCLI or web client, right? Or sorry, the VMKFS tools, I would manually clone the two VMDKs from the snapshot, right? And once I do that, I would have to then go to the Oracle RMAN virtual machine, edit settings. I would have to add these two VMDKs as existing disk to a new SCSI controller. And once we do that, the Oracle RMAN now has 4 VMDKs, just to keep it simple, 2 VMDKs original and the 2 new VMDKs that we cloned from the Oracle virtual machine, the Oracle database server. And the rest of the steps are the same as before. But using this Pure plugin, that makes life very simple, right? That alleviates or that removes all these manual steps, and you're able to put it as a workflow, right? That way, these manual steps are avoided. All right, so we looked at backup and recovery as a first use case, right? Let's look at database cloning using a vVol-based snapshot as a second use case here. Okay. We have two virtual machines. You have the database server on the left-hand side. You have the mount server on the right-hand side, right? And again, both these virtual machines had OEL 8.3, UEK, right? Unbreakable kernel, 19.8, grid, ASM, grid and RDBMS with Oracle ASM and ASM library here. Again, just to keep things simple, the Oracle database server has 2 VMDKs. It has more than 2 VMDKs, but just for the sake of discussion, has the data and the FRA disk. The server or the virtual machine on the right, the mount server, right? It has essentially no database there. It just has the ASM installed. Because remember, we'll be taking a snapshot, cloning it, and then we would be then mounting that disk onto the mount virtual machine, right? So the use case here is to clone the Oracle database to a QA virtual machine for any kind of testing purposes. Let's say the QA department, they want to test a new version of the software code, or they want to test database patching or any kind of new release, or even bug fixes, right? So that's the use case here. Okay. Let's look at, okay, so these are the steps when we do cloning using the VMware snapshot and vVol. Essentially, we would again take, in this case, we have the ability to take a VMDK level snapshot, right, using the Pure Storage plugin. So you can either take a VM level snapshot, which we have been doing traditionally for so many years by saying, take a snapshot of the virtual machine, or using that Pure Storage plugin, you have the ability to take a snapshot of the VMDKs that is of interest here, which essentially is your data and your FRA. Use the same plugin on the mount virtual machine, which means the virtual machine on the right-hand side. Use the import disk, in this case, to create the 2 new VMDKs. And once you're there, the rest of the steps are exactly the same as we saw with the previous use case, right? You would scan the bus for the new ASM devices. You would mount the disk group. You would start the database up. Typically, people change the name of the database and also the database ID because you don't want to get confused with the production database that's running up here. And now your new database is ready for a variety of database purposes, right? Whether you have to test a new version of software or testing patching or any kind of bug fixes and so on and so forth. Again, this use case has been described in detail in the white paper, and the link is there at the bottom of the slide here. Okay. So essentially, this white paper has a lot more use cases than what time permitted us to discuss on the call here today, right? Essentially, it goes into the database backup using vVol-based snapshots and Oracle RMAN, the restore and recovery using vVol-based snapshots and Oracle mechanism, right? Cloning using vVol-based snapshots, database refresh using vVol-based snapshot, patching, provisioning, cloning, and all of those use cases. And they pertain to both the flavors, right? Both single instance and Oracle RAC, right? And I think that was, the caveat with Oracle RAC is, essentially when you have, or when you're running Oracle RAC on a VMware vSphere platform, and you're using VMDKs, the way that you would do it is you would use the multi-writer attribute, right? You would use the multi-writer attribute to share those VMDKs among multiple virtual machines that comprise the Oracle RAC cluster. And as per KB article 1034165 for VMFS, or 212.1181 for vSAN, certain operations are disallowed, like for example CBT or snapshot. So you inherently cannot take a virtual machine snapshot of an Oracle RAC or of a VM that is part of an Oracle RAC cluster, which has shared devices or shared VMDKs using the multi-writer disk, right? So essentially you would have to use a combination of two ways to do it, right? Using the VM level snapshot for the non-shared devices and using another level snapshot for the shared devices, and then mounting that shared device snapshot of the shared devices on another server for backup. But the white paper goes into all of those details, right? How you're able to back up an Oracle RAC cluster, how you're able to clone an Oracle RAC cluster, how can you clone a RAC cluster for, let's say, patching and so on and so forth. It goes into a lot of detail here. But moving on. So, I mean, in conclusion, right? DB as a service using vVols, right? We all understood what business critical workloads are. Again, Oracle is not in particular here. That could pertain to the SQL servers, the SAPs, the Microsoft, and what you have running in a shop, which is deemed business critical, which has stringent SLAs, which has stringent RTO and RPO. And typically, if you look at the database, if you look at the Oracle landscape, right, these business critical databases, they're among the last, right? They are the last bastion to be conquered because of the challenges posed as these workloads grow up, they scale up, they scale out, essentially with day two operations, right? And the ask of the day or the ask of the hour is meeting strict business SLAs for performance, right? Making sure that you're able to manage these rapidly growing production databases. We need to make sure that we adhere to the backup window. We don't spill our operations outside the backup window, because that's going to affect that'll have a domino effect. That'll affect other operation schedules and so on and so forth, and impact system performance, right? That's some of the reasons, or these are some of the reasons why DBAs, they kind of delay virtualizing the business critical database and workloads, right? And the thing is, the day two operation that is more frequent, that's more prevalent than any other day one operation, right? When we look at installation and configuration, yes, we have these guides that will tell us how to install and configure Oracle databases and Oracle workloads, but Oracle DBAs, most time is spent in these day two operations. Okay, they ask for backup, they ask for recovery, they ask for restores, cloning, refreshes, patching, and so on and so forth. So by using vVols, by using VMware Virtual Volume, where essentially you're able to cut down the time, you're able to provide that speed, the flexibility, the ability, and the performance, along with trying to put all of that in a workflow, right? Whether using VRA, VR, or any kind of automation engine and coming up with a database as service, we are able to cut short that time, right? And make sure that we're able to provide databases on fly to the Oracle DBAs, the Oracle developers, the architects, right? We are able to, that way, our applications, right? We are able to reduce the time for go-to-market. And then we're able to reduce the time for storage administrators and DBAs using SPPM, storage-based policy management. So that way the control is back in the Oracle DBA's hand, and he and she can then provision the databases as per their choice based on the characteristic that the storage array is able to provide using the storage-based policy management, right? And this reference architecture basically validated all of the day two operations, and it speaks to all these use cases in a greater detail. But moving on, so wrapping up, so essentially, all Oracle on VMware. So all Oracle on vSphere, white papers, right? That includes the hybrid multi-clouds, whether that's vSAN, vSphere, vVol, VMware Clouds, best practices, deployment guides, workload characterization guide, everything and anything can be found in the URL below. Please bookmark it. So, it's aptly called the one-stop shop, and essentially it has a lot of KB articles and a lot of blogs as well. That's a bit about me. Bit about Mohan. But I think we are at the end of the session.